Welcome to our session on air quality and its importance in our daily lives. We'll explore the composition, properties, and challenges of air pollution, along with solutions for improving indoor air quality. Join us in understanding how air impacts health, environment, and sustainability. Air. Air is defined as a mixture of gases, including oxygen, nitrogen, carbon dioxide, and trace amounts of other gases. It has several characteristics. Air takes an indefinite shape and volume, it is colorless and odorless, and despite being invisible, it has mass and weight. Composition of air. The air we breathe is a mixture of gases. The following table shows the percentage of each gas in the air. Nitrogen, 78%. Oxygen, 20.9%. Other gases, 0.17%. Argon, 0.9%. Carbon dioxide, 0.03%. Properties of air. Air is colorless and odorless. This means we cannot see or smell air. Air can be felt. We can feel the wind which is moving air. Air is made of gases. The air we breathe is a mixture of gases like nitrogen, oxygen, carbon dioxide, and others. Air exerts pressure. Air pushes down on everything on Earth. Air occupies space. Air takes up space, and we can see this when we blow up a balloon. Air has mass. Air has weight, even though we can't see it. Air expands. Air can take up more space when it is heated. What is air pollution? Air pollution is any physical, chemical, or biological change in the air that contaminates it. This contamination is often caused by harmful gases, dust, and smoke, which negatively affect plants, animals, and humans. These pollutants can be released from various sources, such as factories, vehicles, and power plants, and can have severe consequences for the environment and public health. Common air pollutants. This image shows a circle diagram that illustrates the common air pollutants. Particulate matter, tiny particles that can be inhaled and cause respiratory problems. Volatile organic compounds, gases emitted from various sources, contributing to smog formation. Sulfur dioxide, a gas produced mainly by burning fossil fuels, causing respiratory irritation. Nitrogen dioxide, a gas from vehicle emissions, contributing to smog and respiratory issues. Ground-level ozone, a harmful gas formed by reactions of pollutants, damaging lungs. Carbon monoxide, a colorless, odorless gas produced by incomplete combustion, causing oxygen deprivation. Effects of air pollution. Air pollution can have far-reaching consequences, impacting human health, social and economic structures, and the environment as a whole. Health-wise, air pollution can lead to chronic bronchitis, lung cancer, emphysema, respiratory allergies, and other illnesses. Socially and economically, it can cause corrosion of metals, damage to buildings, and destruction of plants and animals. Moreover, it contributes to global environmental problems, including greenhouse gas emissions, acid rain, global warming, and increased UV radiation. Indoor air quality, IAQ. Indoor air quality, commonly referred to as IAQ. Definition: IAQ describes the quality of air inside and around buildings and structures. It encompasses factors like pollutant levels, ventilation, and humidity, which all play a role in the environment's overall air quality. Impact: IAQ has a significant impact on the health, comfort, and well-being of people who occupy the space. Poor air quality can lead to health issues such as allergies, respiratory problems, and fatigue, while good IAQ promotes better productivity, comfort, and overall health. Ensuring optimal IAQ is essential for maintaining a safe and healthy indoor environment. Sources of indoor air pollution. Outside air, air pollution from outside sources like traffic can enter your home. Wood and paper burning, burning wood or paper for heat or cooking releases harmful fumes into the air. Chulhas, traditional stoves that use wood, coal, or dung for cooking emit pollutants. Tobacco, smoke from cigarettes, cigars, and pipes contains toxic chemicals that harm your health. Agarbatti, incense sticks release fine particles and volatile organic compounds that can trigger allergies. Wall and furniture paint, paints and varnishes contain VOCs that can be released into the air, especially during and after application. Dust, dust mites, pet dander, and other allergens can accumulate indoors and cause respiratory problems. Mosquito repellent, Certain chemicals in bug sprays and coils can irritate the lungs and cause other health problems. 10 steps to make healthy indoor quality. Clean. This refers to general cleaning and decluttering of the home to remove dust, dirt, and other allergens. Test for radon. Radon is a radioactive gas that can be harmful to human health. Testing for radon levels and taking steps to mitigate high levels is important. Treat mold and asbestos. Mold and asbestos are dangerous and can lead to respiratory problems. Taking steps to treat these issues is important for the health of your home and family. Use carbon monoxide detectors. Carbon monoxide is a colorless and odorless gas that can be deadly. Using carbon monoxide detectors can help to alert you to the presence of this gas. Replace filters. Replacing air filters regularly is important for improving air quality. Lower humidity. Lower humidity levels can help to reduce the growth of mold and mildew. Buy houseplants. Houseplants can help to improve indoor air quality by absorbing pollutants. Use air purifier. Using an air purifier can help to remove pollutants from the air and improve indoor air quality. No smoking indoors. Smoking indoors can lead to poor air quality and health problems. Open windows. Open windows regularly to allow fresh air to circulate. Oven pollutants and their health effects. Ammonia. Cleaning products can release ammonia, which irritates the eyes and mucous membranes. Asbestos. Used as building insulation, asbestos can cause asbestosis, benign pleural disease, fibrosis, mesothelioma, and lung cancer. Bacteria and other microorganisms, Legionella, molds, and mildew can cause worsening of respiratory complaints. Formaldehyde, commonly found in building materials, formaldehyde can irritate the eyes, skin, and mucous membranes, causing headaches and asthma. Radon gas, released by soil and entering buildings through cracks, radon gas increases the likelihood of lung cancer. Methane gas, formed by the decay of natural materials, methane gas is highly flammable and potentially explosive. It reacts violently with oxidizers, halogens, and some halogen-containing compounds, potentially leading to asphyxiation. Levels of screening of assessing IAQ. Initial screening should identify and test majority of air problems. Levels of screening for assessing indoor air quality, IAQ, starting with the initial screening phase. The purpose of initial screening is to identify and test for the majority of common air quality issues. Key indicators include carbon monoxide, a result of inefficient combustion, often from heating systems or vehicles. Carbon dioxide, produced by human metabolism, its levels can indicate ventilation effectiveness. Particulates or dust, originating from various sources like construction materials, outdoor pollution, or indoor activities. Ozone, released by fluorescent lights or office equipment like photocopiers. Legionella bacteria, commonly found in water systems like cooling towers, posing serious health risks. By addressing these factors during initial IAQ screening, facilities can identify and mitigate potential air quality concerns early on. Intensive screening for IAQ. Intensive screening for indoor air quality, or IAQ, which is critical for creating healthier indoor environments. A more intensive sampling program goes beyond initial tests to measure additional key indicators, such as nicotine. This serves as an indicator of environmental tobacco smoke, which can significantly affect air quality. Organics. These include odors and specific toxic substances that may be present in the air. Formaldehyde, a common irritant, known for its toxicity, which is often released from building materials and furnishings. Radon, a naturally occurring radioactive gas that may be present due to certain building materials or geological conditions. By expanding IAQ tests to include these factors, facilities can better identify potential risks and take steps to ensure a safer, healthier environment. Action plan to improve IAQ. Steps. Eliminating, or reducing pollutant at source. This involves identifying the sources of pollutants and taking steps to eliminate or reduce them. Filtration, or air purification. This involves using air filters or other purification systems to remove pollutants from the air. Ventilation, or dilution of pollutants. This involves increasing the amount of fresh air in the space by opening windows, using fans, or installing ventilation systems. 4 steps to improving IAQ. The document describes 4 steps to improve indoor air quality, IAQ, with each step leading to greater costs. More frequent replacement of air filters. This involves replacing air filters more often. Use of a more efficient air filtration method. This involves upgrading the air filtration system to a more efficient one. Increasing the outside air ratio and implementing enthalpy control. This involves increasing the amount of fresh air brought into the building and implementing enthalpy control systems for optimal humidity and temperature management. Major redesign of the HVAC system. This involves a complete overhaul of the HVAC system, including supply, upgrading the air supply system, exhaust fans, installing more efficient exhaust fans, control of the outside air ratio vs return air, implementing advanced controls for managing air ratios, heat recovery, installing heat recovery systems to minimize energy loss, automatic controls, automating HVAC functions for optimal efficiency and performance. The Air Quality Index, AQI, is a measure of air quality that is used to report daily air quality. It tells how clean or polluted the air is. An AQI of 0 to 50 is considered good, 51 to 100 is satisfactory, 101 to 200 is moderate, 201 to 300 is poor, 301 to 400 is very poor, and 401 to 500 is severe. Outdoor air quality. Outdoor air is often referred to as ambient air. Common sources of outdoor air pollution include emissions from combustion processes, particularly from motor vehicles, solid fuel burning, and industrial activities. Air pollutants. The pie chart depicts the contributions of various sectors to air pollutants. Sectors and their contributions. Industry, 52%. Transportation, 27%. Consumer and commercial products, 8%. Agriculture, 10%. Residential, 1%. This chart shows that the majority of air pollutants, 52%, come from industrial activities, followed by transportation, 27%. Agriculture and consumer commercial products contribute significantly less, 10% and 8% respectively. Residential sources contribute the least, 1%. Effects of air emissions. Air emissions can lead to severe environmental consequences. They contribute to the destruction of the ozone layer, increased UVB radiation, vector-borne illnesses, acid rain, decay of forests, pollution of soils and plants, and human health issues from ingestion and inhalation. Additionally, they can lead to stress and exacerbate heat waves. Hotels and external air pollution. In hotels, various pollutants originate from different sources. Emissions from burning fossil fuels include those from boilers used for steam and hot water generation, vehicles, and gas-fired kitchen equipment. Hydrocarbon emissions arise from the use or spillage of petrol and diesel, as well as from pesticides containing chlorinated hydrocarbons. Ozone-depleting substances, including CFCs, often come from refrigerant loss in old appliances and aerosol spray cans. Odors and vapors from kitchen and laundry exhausts, along with volatile organic compounds like spray paints, also contribute to air pollution. Furthermore, bacteriological pollutants can be found in cooling towers, swimming pools, and various hotel facilities. Other miscellaneous gases, such as formaldehyde and trihalogenmethane, along with particulates like asbestos and lint, add to the pollution burden. Air emissions management. The goal of managing and reducing air emissions is multifaceted. It aims to provide a healthier environment for both employees and guests, protect the global environment, and reduce operating costs by cutting fuel bills and extending the lifespan of equipment. CFCs and refrigeration management. CFCs, or chlorofluorocarbons, along with HCFCs, are gases that possess low toxicity, are non-flammable, and are highly stable. They serve as excellent refrigerants. However, CFCs are known to destroy the ozone layer in the upper atmosphere when exposed to the sun's ultraviolet radiation. Common refrigerants and its alternatives. Several common refrigerants and their alternatives include CFCs like R11 and R12, HCFCs like R123 and R22, and HFCs such as R134A. Natural refrigerants include options like R290 and R717. Transitioning to these alternatives is essential for reducing environmental impact. Strategic refrigeration management. Effective strategic refrigeration management involves several key steps. First, appoint a dedicated team to oversee the process. Then, Prepare an inventory of all refrigeration equipment, monitor usage, and test for leaks regularly. Maintaining contact with suppliers, keeping standards up to date, monitoring the availability of alternatives, reviewing compliance, and considering all available options are also crucial. Finally, implement decisions and continuously monitor and review progress. Noise pollution. Noise pollution is defined as any unwanted or disturbing sound that negatively affects the health and well-being of humans and other organisms. It can lead to a range of health issues and decreased quality of life. Source of noise in hotels. In hotels, various sources contribute to noise pollution. Traffic from vehicles around the resort, including delivery and waste removal vehicles, can be disruptive. Construction, renovation, and maintenance work also adds to the noise levels. Equipment and systems, such as air conditioning, ventilation, and kitchen machinery, contribute to the background noise. Entertainment activities, including discos and live music, as well as everyday sounds from guest rooms, such as phone conversations, television, and moving furniture, can also impact the overall noise environment. Hierarchy of controls for noise hazard. Eliminate the noise. The most effective approach is to completely eliminate the noise source. This could involve redesigning processes to remove the hazard entirely. Replace the hazard. If elimination isn't possible, consider replacing noisy equipment with quieter alternatives. This can significantly decrease noise levels and improve the work environment. Buy quiet equipment and tools. Investing in tools and machinery designed to operate at lower noise levels is crucial. Selecting quieter options can greatly reduce worker exposure to harmful noise. Control the noise. Implementing engineering controls is another effective method. This includes using barriers or sound dampening materials to minimize noise transmission throughout the workspace. Isolate people from the hazard. Creating physical separations between workers and noisy areas is important. This could involve redesigning workspaces to keep workers away from the sources of noise. Exposure time limits. It's essential to implement policies that limit the amount of time workers spend in noisy environments. By reducing overall exposure, we can mitigate potential health risks. Change the way people work. Modifying work practices can also help minimize noise exposure. For example, scheduling noisy tasks during off-peak hours can significantly reduce the impact on workers. Protect the worker with personal protective equipment, PPE as a last resort. Providing appropriate PPE, such as earplugs or earmuffs, can protect workers from harmful noise levels. While this is not the first line of defense, it remains an important option for ensuring worker safety. Thank you for your attention. For more details, please contact TSD Office Engineering GHG. We appreciate your interest in ESG initiatives.